All right, so for today we are just going to keep adding and subtracting rational expressions. So just a refresher from what we did yesterday, finding the least common multiples. First step is to find the prime factors of each expression, which means we have to factor it. That's what we put in that dash dash blank afterwards. Just factor, big old factor. Factor everything we can in the denominator. Write each prime factor the greatest number of times it appears in either expression, and then simplify. When we are doing this with adding and subtracting rational numbers, or rational expressions, I should say, we do it a little bit differently, or at least we talked about doing it a little differently, but this is another way that we could do it instead of doing the what is it missing idea that we talked about. Again, same blanks from yesterday, so even if you have yesterday's notes, you could just copy those over. Okay, so let's practice that. Step 1 is to factor these expressions. So we're finding the least common multiple of 5x squared plus 15x plus 10 and of 2x squared minus 8. Give you a moment to write that down. And then we start factoring. So let's start with this first expression. What's the first thing I could factor from that?
5.
A 5, and what would be left? Good, and we can factor that further. What would that parentheses factor into for two binomials? Good. All right, the other expression, when we start to factor, we first factor out a GCF, which is 2. What's left? Minus 4, good. And then we can keep our GCF, but factor the difference of two squares.
X plus 2, x minus.
Good. X plus 2, x minus 2. All right, so if we're following the steps of finding the least common multiple, then we would want to write down each factor the greatest number of times it appears in either expression. But each factor only appears a total of one time at a time. Does that make sense? Mm-hmm. So if these were denominators, we would be thinking about what does one need for them to match up. So we know we're going to have a 5. What other whole number are we going to have?
2.
A 2. Right? Each of those only occurs one time, but we have to look at either one of these and pull from both. What other factors would we have?
X plus 1.
We'd have an x plus 1. It occurs one time.
X minus 2.
X minus 2. And what else? X plus 2. Should I write down the x plus 2 one time or two times? One time. So we kind of have to think about these as like two separate things. The greatest number of times it appears in either expression. It only occurs one time on either side, so we can only write it down once here. Does that make sense? Yes. Okay, and yesterday we talked about the fact that I'm fine with you leaving this mostly factored out. If you wanted to simplify it a little bit, some quick ways to simplify it would be to multiply the 10 and then to also multiply back here, because this would give us the difference of two squares, x squared minus 4. In general, though, when we're doing this for adding and subtracting rational expressions, I'm going to be fine if you leave it factored, because we're going to want to try to see if we can cancel anything out. Most of the time that doesn't work out anyway, but we can always try. Questions about number 1 before we do number 2? Okay. Number 2, we're still just practicing the whole factoring and finding the least common multiple. This time we've got 2x squared minus 8x plus 8 and 15x squared minus 60. On that first expression, what could I factor first? A 2 is a GCF, and what's left? Minus 4x plus 4. Okay, the 2's outside the parentheses. And all squished right there. Minus 4x plus 4. Okay. And then I believe we could factor this further.
2x minus 2x minus 2.
Good. Both x minus 2's. We keep the 2 out in front. Stays there. We jump over to our other expression. What could we factor? A 15, and what's left? X squared minus 4. We can factor that more. Good. X plus 2, x minus 2, still with the 15 out in front. So we look at these two sides kind of as separate expressions. And we think about how many times does each factor need to appear for our least common multiple. So what do I know will be on my least common multiple list?
2.
The 2 and the 15 for sure. Technically, we should have broken down this 15 to be what times what? 3 times 5, but since there weren't any 3's or 5's over here, it's not really going to affect us. If there had been a 3's or 5's over here, then that could have affected the next step if we didn't split that up. Okay, moving on. What else?
X minus 2.
X minus 2. How many x minus 2's should I write down?
1 or 2.
2. Why?
Because there's 2 in the first one.
2 and the first one. So we want the greatest number of times it appears in one expression. So it appeared twice over here. We're going to write down x minus 2 twice. What else? We still need an x plus 2 from this other expression. Again, we could simplify this a little bit. 2 times 15 would give me 30. And we could multiply one of the x plus 2's minus 2's together.
X squared
Minus 4.
So that simplifies it a little bit pretty quickly. We could double distribute the x minus 2 to the x squared minus 4 and then distribute a 30, but I'm not requiring you to take all those steps just because they're not really necessary. They're kind of extra at this point. You should be able to do that. I'm just not making you do it. Okay, ready to move on?
Yes.
Now these are the ones that I believe actually get a little more interesting. Remember that third step, for whatever reason, isn't really in here. The third step should say to rewrite. Again, same notes as yesterday. We are going to find the least common denominator. It is the least common multiple of the denominators. We rewrite the fractions with a common denominator. We also then, that third step should be rewrite numerators accordingly. It all gets rewritten. We add or subtract whatever the problem's telling us to do, and then we simplify however we can. So we always are going to have to multiply out our numerators so that we can combine like terms when we add or subtract. You can leave your denominators in factored form if you want to. So if you want to make yourself a little note, multiply out numerators. You can make that little note off to the side. We will always have to multiply out the numerators, but our denominators we could leave in factored form. All right, remember when we did these yesterday, if you were here, we started out by factoring our denominators so that we could start identifying our common denominator or least common multiple. So for right now, our numerators are staying the same. How could I factor that first denominator?
You put
I think you were right. Yep, x minus 6, x plus 2. That would multiply to a negative 12 and add up to a negative 4. What about my other one? Factor out 4. What's left? X plus 2. Now, you might notice that I wrote this a little bit in the middle of the slide so that I still had room to write on either side of it. I did that for a reason. After we have factored out our denominators, you could identify your least common denominator using the steps we were doing on the last couple problems. But a little bit easier of a way that I think of doing that is to compare the denominators and think they want to be exactly the same. So what does this second denominator have that the first denominator would want?
4.
A 4. So we need to multiply this denominator by a 4, but that means we also have to multiply the top or the numerator by a 4. Now we've got to do the same thing for our second denominator. We've got to look at it and think, well, now, what is it going to want so that it matches the first one? The x minus 6. So we're going to multiply the denominator by an x minus 6, but that means we do the same thing to the numerator. Questions about that step? We didn't have to mess with the x plus 2. Why not?
Because both of them.
They both had it already, so we didn't have to worry about it. Okay, next step, we are going to rewrite. So 4 times 1 gives me 4 in that numerator. For now, I'm just going to put one big fraction bar. X minus 6, x plus 2. So then I know that I am adding, so I'll put a plus sign after my 4. They have a common denominator. That's why I'm writing one big fraction bar this time. They've already got a common denominator. Somebody whispered it. Was that you, Jacob?
Yeah.
Okay, what did you do to come up with that?
Distribute.
Good. We have to distribute the 3x into this binomial back here. So that gives us 3x squared minus 18x. I like addition problems when we've got a big plus sign in the middle, because then I don't have to worry about if the signs in the back are going to change or not. When we have a subtraction problem, then we also, in addition to multiplying things out, have to change our signs. But for an addition problem, we don't have to worry about that step. All right, next thing we need to do is kind of clean this up a little bit. What do you think I could do to clean up this numerator? Or make it look more like we would usually see them. Put it in a standard form.
3x squared minus 18x.
Good. 3x squared minus 18x plus 4. Will any of those things combine?
No.
Nope, none of them are like terms. Our denominator is still its common denominator. Notice now that when we write it all together, we should not be tempted to cancel off these 4s. Yesterday, some people were tempted to go ahead and cancel those out. But if you do that at any time, if you do it early enough when it would be legal to do, you're then working backwards, because then you're leaving yourself with a 1 again. But if you do it after you've combined your denominators, so you've got one big fraction, then it's just illegal. You can't just cross those off. And I think when we see it in standard form, it's easier to see why. You can't just cancel out those 4s. Or at least I hope so. Now, what should we be checking to see if we could do? A GCF or factor it somehow? Is there a GCF? No. And I would venture to say I don't think we can factor that even using bubbles. Okay, because if we multiply 3 times 4, what do we get? 12. And there are no factor pairs of 12 that are going to add up to an 18. So, if we could factor the top, we would want to, especially a GCF, but we can't. So that's our answer. Questions about example 3? Questions? Nothing? Okay. Here's example 4. What's something about this problem that we need to worry about that we did not have to worry about last time? What kind of problem is it? Subtraction. So at some point, at some point we're going to have to worry about changing signs in our second numerator. We don't have to worry about it right away, but it's just something to be aware of that we're going to have to do later. But we're going to start off just like we have been. We need to factor our denominators. What will the first denominator factor into?
2y minus
y
3, y plus 1.
minus 3, y plus 1. I would agree that multiplies to negative 3, adds up to negative 2. What about my other denominator?
4y plus 1.
Good, factor out of 4. So 4 times y plus 1. Now we need to compare so that we can even up our denominators and make them the same. What is the first denominator going to be missing? A 4. So we also multiply it to the numerator. What is the second fraction missing? Y minus 3. So we multiply that to the numerator and the denominator. All right, on my next step, I'm going to write it with the common denominator, 4 times y minus 3 times y plus 1. Okay, my first numerator, what does it become? 8y. This is a subtraction problem, so I'm going to put a minus sign and then parentheses to help remind myself that on my next step, my signs are going to have to change. So in that parentheses, what am I going to need?
3y plus 1.
Careful.
3y minus 9?
3y minus 9. I have not changed any signs yet. I kept it a subtraction problem, and I put parentheses there. How did we get 3y minus 9? We distributed the 3 from up top. Okay, so then some of you, I believe, would be able to distribute and change your signs at the same time. But some people, I think, need to just keep it one step at a time, not try to jump ahead. So now we're going to distribute the negative or the minus sign. So we would have 8y minus 3y plus 9. Good. All over 4 times y minus 3 times y plus 1. Do we have any questions about how we got here?
Is that the answer?
It is not the answer. What can we do?
Combine like terms.
We can combine like terms on this one. What can combine?
8 and 3y.
The 8y minus 3y gives me
5y.
5y, still plus 9 over 4 times y minus 3 times y plus 1. Can anything else simplify, combine, or factor?
No.
No. So if nothing else simplifies, combines, or factors, we have our answer. Questions about example 4? All right, let's just real quick talk about what we got when we factored to make sure we all got there together. When we factored our first denominator, what did we get?
3x plus 5x plus 2.
That sounds good to me. Do we have questions about how we got there? First a GCF, then split it to 2 binomials. What about our other denominator?
3 and then x plus 5.
Good. So this one is a little bit interesting because if we look at our first denominator, is it missing anything that the other one has?
Yeah.
No.
No, the other one did.
Okay, so the second denominator is missing something. But the first one, it's not jealous of or wanting anything that the second denominator has. So we actually don't have to change this first fraction at all. Does that make sense?
Yes.
Okay, but the second one, what is it missing?
X plus 2.
The x plus 2. So this one's going to get an x plus 2 multiplied on top and on bottom. But the other one gets to stay the same. It's nice that this is an addition problem because I don't have to worry about the changing signs part.
I'm multiplied instead of added.
Oh no. Okay, so I copied down the 1 plus because that first one didn't change at all, nothing to multiply to it. But the second numerator, what am I going to have to do?
4x squared plus 8x.
Good, 4x squared plus 8x because we had to distribute. Now on our next step, we should just clean it up. How would we want to rewrite this?
4x squared plus 8x plus 1.
Good. We should check to see if we could factor this, but is there a GCF?
No.
No. Do we think we can do bubbles?
No.
No. If we take 4 times 1, we get 4. There are no factors of 4 that would add up to 8. So it cannot be factored. We leave it alone. Now, technically, some teachers at some point in your mathematics career, now in college, sometime, might want you to multiply out the denominator again, but I am not requiring you to do that. I think it's an extra step that we don't have to do to demonstrate our knowledge of this process. First step is always to factor our denominators. What did the first one factor into? 3x minus 2, x minus 1. I would agree. Did we all get that for our first denominator?
Yes.
Good. What about our second one?
3x minus 1x plus 2.
X minus 1, x plus 2. Good. Did we get that one for our second denominator?
Yes.
Okay. What does the first denominator need that the second one has?
X plus 2.
An x plus 2. Good. So put that on top and bottom. What does the second denominator need that the first one has?
X minus 2.
The x minus 2. Good. Now this one's going to be a little bit different from ones that we've seen because we've got a binomial in this numerator. So if it were me, I would go ahead and throw some parentheses around that binomial in your second numerator. That might help us when we get to that part. Do we have questions about figuring out what the denominators need? Okay. So on our next step, we're going to have a big fraction bar. Our denominators are going to be the same now. It doesn't really matter to me what order you put your factors in as long as they're all there. So we should have a 3, an x plus 2, an x minus 2, and an x minus 1. Since we're multiplying, it doesn't really matter what order our factors go in. All right, in my numerator, what am I going to do to figure out how to simplify this first numerator?
Distribute the x.
Good, we have to distribute the x, even though it's kind of backwards from where we usually look to distribute. It's the same idea. What do we get? X squared plus 2x. This is a subtraction problem, so I'm going to put a minus sign and then put up some parentheses. Just to remind myself that I need to change signs for that piece on the next step. Now, coming up with what goes in those parentheses can be a little bit tricky. So I'm going to kind of do that off to the side here. 2x squared, how'd you come up with that?
2 times 2. X.
Okay, so we are essentially double distributing. Do we remember this, multiplying two binomials together?
Yeah.
So we multiply the 2x times the x, we got 2x squared. Then we have to multiply 2x times negative 2. What do we get?
Negative 4x.
Negative 4x. Next, what are we going to distribute?
The 1.
The 1.
Plus x.
So plus x
Minus 2.
minus 2. Now I was running out of room, so I stacked them instead of writing it all out to the side. What do we need to do now? With combine like terms. So what are we left with?
2x squared minus 3x minus 2.
Good. That is what I'm putting in these parentheses over here, because that's what I would get if I were to multiply the numerator to what I needed to use in the denominator. So 2x squared minus 3x minus 2. We have questions about that part? That's something we have not done together yet. Okay, now we still have to switch the signs in the back part. So we've got x squared plus 2x. Good. Good. So we switched all the signs for that parentheses that we had in that trinomial. Our denominator is still the same. 3 times x plus 2 times x minus 2 times x minus 1. Now what do we notice that we can do? Combine like terms. So I'm going to move down here to the bottom instead of being off to the side. What terms can I combine?
The x squared.
We can combine the x squared. So x squared minus 2x squared. A negative x squared. What else?
The 2x and
Good. 2x and 3x combines to give me
5x.
a positive 5x. What else? Plus 2. There's nothing to combine with it. My denominator is still the same. 3 times x plus 2 times x minus 2 times x minus 1. Now, you could factor out a negative and check to see if what's left over factors more, but it doesn't. I'll just go ahead and spoil the surprise. This is not going to factor anymore, so that is where we will leave our answer. Now, if you got stuck, did you figure out where and why and how to fix it? Good. Do we have questions about 6?